Hi, welcome back to my channel Physics from 5 SSM. Today we continue Chapter 5 Electronics on topic 5.2 Semiconductor Diodes. First of all, let's discuss about energy bands of electrons. Electrons are arranged in a certain energy level. There are three levels here. The first one is conduction band for current conduction, forbidden range that separates between conduction and valence band, which is no electron is allowed here. Valence band, electrons valence are here. Let's look at insulator, example plastic and wood. For insulator, conduction band and valence band are separated by thicker forbidden range. When an insulator is heated, electrons gains energy, but electrons in valence band cannot jump to conduction band due to large difference in energy level. Thus, at higher temperature, insulator cannot conduct electricity because no electron in conduction band. For conductor, example metal, no gap between conduction band and valence band, or we can see conduction band and valence band are overlap. Electrons were able to be in conduction band due to no difference in energy level. Conductor can conduct electricity because there are electrons in conduction band even at room temperature. For semiconductor, example silicon, valence band and conduction band are separated by thinner forbidden range, meaning small difference in energy level. At room temperature, valence electron will stay in valence band, no electrons in conduction band. At high temperature, electron in valence band gain energy and able to jump to conduction band. Thus, at high temperature, there is electron in conduction band that cause semiconductor to conduct electricity. Let's explain more. At room temperature, there are no electrons in conduction band. Thus, semiconductor cannot conduct electricity at low temperature. At higher temperature, electrons were able to jump into conduction band due to smaller difference in energy level. Semiconductor can conduct electricity because there are electrons in conduction band at higher temperature. The movement of electrons to conduction band produces hole in the valence bands. That's the reason why semiconductor has two charge carrier, electrons and holes. There are two types of semiconductor, intrinsic, which is pure form of semiconductors, and extrinsic, impurities are added to improve conductivity. How to improve conductivity of semiconductor? The process used is doping process of adding impurities into structure of pure semiconductor, intrinsic semiconductor, to increase conductivity of semiconductor and decrease its resistivity. The doping process will increase the conductivity of semiconductor. There are two types of doping process. The first one is using trivalent atom, example boron B. Boron has 3 valence electrons and form a 4 covalent bond by receiving 1 electron from neighboring silicon. The movement of electrons created a lot of holes in the structure of extrinsic semiconductor. The holes become majority charge carrier. That's why we call it p-type semiconductor or positive type semiconductor. The second type of doping process is using pentavalent atom, for example phosphorus P. Phosphorus has 5 valent atoms and form 4 covalent bonds with the neighboring silicon and leave 1 free electron. The addition of pentavalent atom produces a lot of free electrons in the structure of extrinsic semiconductor. The electrons become the majority charge carrier. So we call this type of semiconductor is n-type semiconductor or negative type semiconductor. The combinations of p-type and n-type semiconductors results in a junction. This combination has many applications in electronic devices. So combination, we call it p-n junction. When p-type semiconductor and n-type semiconductor is joined together, electrons from n-type cross the junction and leave region of positively charged. P-type receive electrons and created region of negatively charged. The positive region that created in n-type semiconductor and negative region in p-type semiconductor will produce potential difference across the junction. The potential difference across the junction is called potential barrier, as it prevents further movement of holes and electrons. The region that created at the junction, we call it depletion region. The PN junction that created with certain value of potential barrier at depletion region, we call it diodes. So diodes is also known as PN junction. That's all my video today. Thank you for watching. Bye.